Hey guys, this is the first example for lesson 1.1, and this is where we're solving an absolute value equation where there's one absolute value on one side and another absolute value on the other side. So there's two ways to do this. So we're going to run through the first method, which is a more traditional one that you learned back in Algebra 1 or maybe Algebra 2. And it goes like this. So you take whichever absolute value that you want to isolate. In this case, I always kind of go with the one on the left. And I would say 3x plus 4 is equal to x plus 5. Okay, so we drop the absolute value bars on the left. We equal it to the positive version of what's on the right, which is always just going to be the original piece that's given to you. And then, or we take the absolute value to the left, we drop the absolute value bars, and we equal it to the negative of the value that's on the right. Okay, and we're going to go through both of these and solve each one individually. And this one on the left, if I move the x over, it would be 2x is equal to 1 when I move the 4 over. And divide both sides by 2, you get x equals 1/2. Or come over here to the right one, and you have 3x plus 4 is equal to negative x minus 5. And when you move your x's to the one side, you would get 4x, move the 4 over, is equal to negative 9. Divide both sides by 4, and you get x is equal to negative 9 over 4. So those are your two answers. X could be 1/2, or x could be negative 9 over 4. Now that's the first way, and that's probably what a lot of you guys are used to doing. Here's the second method, which goes back to one of the key ideas that you guys learned in the notes, which says that in the event where you have an absolute value equal to another absolute value, you could square both sides and set them equal to each other. So we will do that. So if we take 3x plus 4 quantity squared is equal to the quantity of x plus 5 squared. Now, if you remember from AS level, we went through and learned how to quickly expand these binomials without actually having to rewrite a ton of stuff. So the shortcut goes, you take the first term, which is 3x, and you square it. So that would be 9x squared. And the second term is the product of each of these terms. So if you take the product, that would be 12x, double it. So you have 24x. And then you take the last term, which is 4, and you square it. So 16. Now if you do the same thing on the right, you'll end up with x squared plus 10x plus 25. And get all your terms to one side. So that would result in 8x squared plus 14x minus 9 is equal to 0. So since it's a quadratic, we always set our quadratics equal to 0 before we solve them. And in this case, we have a leading coefficient of 8 that we cannot factor out. There's no really greatest common factor that we can do. So we have to factor it as it is. And there's a couple methods. I leave this up to you guys. You can guess and check. You can factor using a box method or whatever it is that you learned and you feel comfortable with. I use a method called the surefire method, or it's also referred to as the AC method, where you take the first two terms, the A value and the C value in the quadratic, and you multiply them. So you get negative 72. And if you read my work, when I publish all my worked out solutions to you guys, you'll always see this done off in the side. So my product is negative 72, and I'm trying to find two numbers that multiply to be negative 72 that add up to be 14. And my two numbers are 18 and negative 4. Okay, and that took me a couple times to get, so don't get discouraged if you can't get it on the first try. But just keep trying and plugging away on your calculator till you get it. So what you do now is you rewrite this quadratic using those two values as that linear term. So you're going to have 18x minus 4x minus 9. So basically you've just rewritten and you've expanded your original quadratic that you're solving. So the next step is to factor by grouping. So we're going to group these first two terms, and then we're going to group these last two terms. Okay, and I always leave this middle sign, this negative sign, out of that second group, just to show me that I'm not actually just factoring here. I'm dividing it right at that sign, that plus or minus sign. So in the first group, the greatest common factor that I can take out is a 2x. So when I take that out, I'm left with 4x plus 9. Okay, now come over to the second group. This minus sign drops straight down. Okay, and there's really not a common factor between -4 and -9 except -1, right? So what we're taking out is -1, but we've already dropped that minus sign down just as a reminder to us that it's going to be a negative value. So that -1 comes out, and we're left with positive 4x plus 9 equals 0. Okay, now notice when we do this method, what we are left with, our leftovers here, are always going to be the same. It's our common factor. Okay, so we're still kind of factoring here, and we're factoring out that greatest common factor. So to finish this off, we take both of the values that we took out, which are the 2x and the -1. They come together in a factor, and then we write that common factor, 4x plus 9. So that is the factorization from this step right down here, okay? Now, like I said before, you're welcome to factor however it is that you want to, but this allows us to solve each of these individual factors for our two values of x. And just because it's been a while probably since you guys have done these, I'm going to not shorthand you here. So to solve this quadratic, you set each factor equal to 0, and you get x equals 1/2 or x equals -9/4, which are our exact same solutions that we got using the first method. So it's totally up to you how you want to solve it whenever you guys have an equation that presents with an absolute value equal to an absolute value.